Everyday browsers block attacks that most users never even notice. Fake websites, malicious scripts, hidden requests, stolen sessions, and many more. But what do these attacks actually look like? And why do modern browsers need so many security features to defend against them? Today, we'll explore some of the most common web attacks and see how browsers and modern web applications help reduce their impact. Let's go inside. Let's start with phishing. Unlike many technical attacks, phishing often targets people rather than software. An attacker creates a fake website that looks nearly identical to a trusted site. For example, a fake banking login page. The goal is simple. Convince the user to enter sensitive information such as usernames, passwords, or payment details. The browser cannot always determine whether a website is genuinely trustworthy. But modern browsers help by warning users about known phishing sites, showing security indicators, and helping users verify website addresses. Password managers also help because they typically recognize legitimate domains and are less likely to autofill credentials on fake websites. Next, cross-site scripting, commonly called XSS. This happens when attacker-controlled content is executed as JavaScript inside a trusted website. Imagine a website displays user-generated content without properly handling it. An attacker manages to inject malicious script code. When another user visits the page, the browser may execute that code as if it came from the website itself. This can allow attackers to read page content, modify the user interface, perform actions on behalf of the user, or attempt to steal sensitive information. To reduce this risk, developers use output encoding, input sanitization, and security mechanisms such as Content Security Policy, or CSP. Now let's look at cross-site request forgery, often called CSRF. In this attack, the attacker doesn't need to steal your password. Instead, they try to trick your browser into sending a request to a website where you're already logged in. For example, you are logged into your banking website. Then you visit a malicious website. That site attempts to trigger a request to the bank. If proper protections are missing, the browser may include your existing authentication information. To defend against this, modern applications use CSRF tokens and same-site cookie protections. Next, clickjacking. Clickjacking is a user interface attack. The attacker places a legitimate website inside a hidden or transparent frame. The user believes they are clicking one button, but in reality, they are interacting with something else. The goal might be approving a permission, submitting a request, or performing an action the user never intended. Browsers and websites defend against this using protections such as X-frame options and Content Security Policy frame restrictions. Now let's talk about session hijacking. When you successfully log into a website, the browser usually stores information that allows the server to recognize you on future requests. This is often done using session cookies. If an attacker manages to obtain those session credentials, they may be able to impersonate the user without needing the user's password. This is why HTTPS, HTTP-only cookies, secure cookies, and proper session management are so important. Another common threat involves malicious downloads. An attacker may disguise harmful software as a useful document, application, or browser extension. The goal is to convince the user to download and run it. Modern browsers help reduce this risk through download warnings, reputation systems, security checks, and sandboxing technologies. Looking at all these attacks, a pattern begins to emerge. Phishing targets users. XSS targets trust within a website. CSRF abuses existing authentication. Clickjacking manipulates user interactions. Session hijacking targets authenticated sessions. And malicious downloads attempt to escape the browser entirely. This is why browser security uses multiple layers of protection. Sandboxing, same origin policy, HTTPS, secure cookies, content security policy, permission systems, and many other defenses. Browser security features were not added randomly. They were created in response to real attacks that repeatedly targeted users and websites. Understanding these attacks helps us understand why modern browsers enforce so many security rules. And it helps us build safer web applications. In the next video, we'll move beyond browser and client-side attacks and explore common backend attack types such as SQL injection, command injection, insecure authentication, and server-side vulnerabilities, and see how attackers target the systems behind modern web applications.